Hello students, in this class we will discuss the common emitter configuration. In the common emitter configuration, you again having the two categories. One will be the input characteristics, the other will be what? Output characteristics. Input characteristics is plotted between this input side, this is the input side, and this will be the output side. In the input side, what is the points you can see here? The common emitter. Emitter is common to both the collector as well as the base. Okay, this is what emitter. Emitter is having the towards the direction of the arrow. Then this will be what NPN transistor and NPN transistor. You can see this point, base and collector. Emitter is grounded, so this is called common emitter configuration. In this we have input and output characteristics. Input is plotted between IB and what is the voltage we have here? VBE. So input is plotted between IB versus VBE, whereas the output is plotted between versus IC versus VCE. IC versus VCE. While we do the input characteristics, input characteristic is plotted between IB versus VBE is the input, whereas the output plotted between IC versus VCE. While we vary this input characteristics, what should be kept constant here? While we vary this input characteristics, VCE should be kept constant. Okay, and in the same way, while we analyze this output characteristics, IC versus VCE, what should be kept constant here? IB should be constant. Okay. Now, if you plot the characteristics here, input characteristics. So it is a graph plotted between VBE and IB. Okay. So this will be what? IB, and this will be what? VBE. If you plot these two graphs, what should be the kept constant here? VCE. VCE should be kept constant. Okay. Under the constant VCE voltage, VBE and IB parameters are varying. What do you mean by IB? IB is the base current, or also called as recombinational current. IB is nothing but recombination current, and VBE is the voltage across the emitter junction. As we have previously discussed, when the input voltage VBE is more than the cut-in voltage, then carriers are injected into base. Then carriers are injected from emitter to base. Then carriers are injected into base, and hence recombinations occur. And hence recombinations occur. occur. Okay, and IB starts increasing gradually. Okay, so what happens if VB is less than VB is not up to the cut-in voltage? For example, this is the cut-in voltage 0.6. Before that, if there is no voltage, if the input voltage is less than this zero point 0.6, current IB will be 0. Okay, the moment when input voltage is exceeding the zero point 0.6, that is cut-in voltage, current starts increasing rapidly. Okay, this is just like the diode forward characteristics. So what is the constant parameter we have here? We have here is VCE3, this is the VCE2, VCE1. Hope you understand this point. So when cut-in voltage, when input voltage is less than the cut-in voltage, no carriers. That implies no carriers means IB value will be 0. Now, now if you apply KVL here, this is what the VBE. Yes or no? This is what VBE. Then in the same way, what is the voltage appearing at this point? This is the collector junction, this is the base junction. Then this will be called as VCB. Yes or no? If I apply outer loop KVL, then what I get here? Minus VCE plus VCB plus VBE equal to 0. Yes or no? Then I want to find the value of VCB because this is the input voltage. VCB is equal to VCE minus VBE. Okay, so that is the input voltage. Hope you understand this point. The next will be the output characteristics. Output characteristics. How many output characteristics will be there? As I said earlier, cutoff, saturation, and active region. Okay. So, so this is the output characteristics plotted between IC versus VCE. What is constant here? IB. Input current should be constant. Input current should be constant. Okay. If you plot, this is IC, this will be VCE. VCE. During cutoff region, the graph where IC is approximately 0, it lies on IB is equal to 0 and to the right of VC is equal to VC saturation. So for example, if this is what the IB cutoff region will be always IC is equal to 0. IC is equal to 0. After that, okay, this point is called VCE SAT, saturation voltage of common emitter, collector emitter voltage. Okay, That implies that implies IB is equal to 0 and to the right of VCE is equal to VCE sat. This will be what? Right. That implies if IB is equal to 0, if IB is equal to 0, then what is the collector current equation? We remember that point. IC is equal to IC is equal to ICE naught. This is the collector current when base is open circuited. ICE naught is equal to, you remember that formula, 1 plus beta into IC naught. Okay, so that was for cutoff region. In case of saturation region where this is the cutoff region. Saturation means if you observe this point, so this will be what? Starting at this point. Okay. In saturation region, a region of the graph where where IC increases with VCE. IC increases with VCE. Okay, IC increases with VCE. Let us take this is the saturation point. Then this point A to B. This is called saturation region. It lies above IB is equal to 0 and to the left of VCE sat. To the left of VCE is equal to VCE sat. So transistor will be in saturation region. Transistor will be saturation region when VCE is less than or equal to VCE sat. At this condition only, transistor will be in saturation region. Q will be in saturation region. I hope this point is clear to everyone. Okay? Thank you.